Hello students, you are welcome to sirMATHS. Today we are going to treat oblique triangles. Oblique triangles. This is for grade 10, or rather grade 11, equivalent to SS2. An oblique triangle is a triangle that is not a right angle triangle. None of the angle is 90 degrees. In other words, an oblique triangle is a non-right angle triangle. The three angles can be acute, or one may be obtuse and the other two will be acute. We call such triangle oblique triangles. And so under these oblique triangles, we are going to treat basically sine rule. The formula for sine rule says that A over sine A equals to B over sine B. This equals to C over sine C. This is derived from a non-right angle triangle, as we are saying. Let this be A, B, C. And let it be the height, and this is 90 degrees. The triangle ABC is a non-right angle triangle. Here is B. Remember that side is a small letter, while the angle is a capital letter. While this is A, and while this is C. And from what you know from SOHCAHTOA, you know that sine A, or rather sine B, let's start with sine B, equals to opposite over hypotenuse, which is H over B, or C. Opposite over hypotenuse, H over C. And this means that H is equal to C sine B. And also sine C, which is this, is equal to opposite. The opposite is H, hypotenuse is B. That will give us that H is equal to B sine C. H is C sine B. The same H is B sine C, which means that B sine C is the same thing as C sine B. Yes. C sine B is equals to B sine C. So here, let's say B sine C divided by sine C sine B. This is the same thing as B sine C over sine C sine B. Here sine C cancel sine C, and here sine C, I beg your pardon, this is B, this is C, and this is B, remember. I take it again, this is sine C, so we have I repeat, this is C, B sine C, divided by sine C sine B. This will give us B C sine B over sine C sine B. This sine C will cancel sine C, giving us B over sine B equals to sine B, cancel sine B, this is C sine C. By so doing, we have B sine B, tallying to this, and C sine C. Similarly, A is also sine A. This is how the formula is derived, that A over sine A is equals to B sine B equals to C sine C. That is for sine rule. And whenever you are solving a problem, as we will discover as we proceed, you will always present the 3. It's true you are using 2 at any point of time, but always present is the way they are. 1, 2, 3, it must be complete. And then you substitute and solve on. Remember, we are treating sine rule, which is a method of solving a non-right angle triangle. That is what we are doing. Now, let us solve one example or 2 to this regard. But before then, sine rule is applied on non-right angle triangle when 2 sides and 1 angle which must be opposite one of the given sides are given, 1, or when 2 angles and 1 side are given. That is when we applied sine rule. I mean, if we have this triangle and we are given A and B, for example, we will be given either this angle which is opposite A or this angle which is opposite B. That is why we say 2 sides and, or rather 2 angles and 1 side. Okay. And 1 angle which must be opposite one of the given sides. Here we have 2 sides. 2 sides are given, side A and side B, and we're given 1 angle. This angle must be opposite this A, or we are given this very other one which is opposite B. That's why we say Sine rule is applied on non-right angle triangle in the situation where two sides are given and one angle which must be opposite one of the given sides, or when two angles are given and any side. If you are given this side, it's already opposite this very angle. We go on with it. Or we are given these sides, it's already opposite this angle. We proceed. Or we are given these sides. Since we're already given two angles, we derive this angle by subtracting the sum of the two given angles from 180 degrees. Whatever it gives us will be this very angle. So we proceed. So I mean, we can be given A, we can be given B, we can be given C. We have something complete to go on. So these are the situations where we apply sine rule. Here is two angles and one side. Are given. In a non-right angle triangle, where we are given this information, any of these, we apply sine rule to solve such a problem. Either we expected to find the ungiven side, we use this very rule, or we are asked to find the remaining angles, we use this. But we must have a situation, any of the two situations, before we apply that. Let's have one or two examples that require the application of sine rule. Here we are told in triangle ABC, we are told that angle C is equal to 53 degrees and side B is equal to 3.36 cm. Also, side C is equal to 4.28 cm. So in this instance, we are given two sides and one angle. And this angle is opposite this given side. In trigonometry, the sketching is very, very important. We sketch the triangle. Our A, B, and C. And then we label the information we are given. We are told that angle C is 53 degrees. And side C is 4.28. While side B is 3.36 or cm. So here we are given two sides and one angle. And this angle is opposite to this very given side. We now produce our formula by saying, in solving this, that A over sine A equals to B over sine B equals to C over sine C. We now pick this, we have 4.28 over sine 53 degrees. And this is equals to, here in the question, we expected to find one of the side. The question says calculate angle B. We are looking for angle B. This is equals to 3.36 over sine B. Remember, we are given this information and we expected to find angle B. And that is what we are looking for. Now we will need our four-figure table, but before then we cross multiply by saying that we have 4.28 sine B. This is equal to 3.36 sine 53 degrees. This is 4.28 sine B, that is equal to 3.36 sine 53 degrees. This times this. Here we single out sine B we are looking for, 4.28 sine B divided by 4.28. This is equal to 3.36 sine 53 divided by 4.28. What you do to the left, you do to the right. So the 4.28 cancel 4.28. Now what we have, we now have sine B equals to 3.36 times. You consult your four-figure table to find angle 53 degrees. You pick your four-figure table. It's better to use four-figure table than calculator sometimes, because calculator may be faulty and may not tell you. We now pick the value of sine 53 degrees from the four-figure table. Here it says 0.7986. 0.7986 divided by 4.28. If you multiply 3.36 times 0.7986, if you do that, it will give you a figure 2.283 divided by 4.28. That will now give us, if we divide 0.6643, this is the value of sine B. Remember, we are looking for angle B. We now say angle B is equals to, we check the value of this in our four-figure table, in the body of the four-figure table, to give us the angle. If we do that, we are going to have 41.63 degrees. We can approximate it is 41.6 degrees. We checked in the body of the four-figure table under sine of angle of sine 66 under 4 difference 3. That will give us 41.63 degrees, and we approximate to 41.6 degrees. So this is the value of angle B in this very particular question. Remember, this is giving two sides and one angle. I hope that is clear to us. Now let us treat a question where we are given two angles and one side, and we are expected to find either the side or the remaining angles. Let's go on. Example 2. In example 2, we are told that in triangle ABC, we are told angle A equals to 29 degrees and angle B equals to 36 degrees, while side B equals to 15.8 cm. And we're expected to find side A. Find A. That's a question. We can as well sketch this. A, B, C. A is 29 degrees and B is 36 degrees, while side B is 15.8. And the question says we should find A. We present the formula that A over sine A equals to B over sine B equals to C over sine C. Small letter is the side, while capital letter is the angle. We now substitute by saying 15.8 over sine 36 degrees is equals to A over sine 29 degrees. We cross multiply, we have A sine 36 equals to 15.8 sine 29 degrees. A sine 36 degrees divided by sine 36 will give us 15.8 sine 29 degrees divided by sine 36 degrees. To single out A, so sine 36 cancel sine 36. So A is equal to 15.8 times, we check for sine 29 degrees from the four-figure table. From the four-figure table. Here in the four-figure table, sine 29 degrees will give us 0.4848. 4848. Remember, so we're looking for sine 29 degrees, sine 29 degrees under 0. Then sine 36 degrees, we also pick it from the four-figure table. Sine 36 says 0.5878. That's the value, 0.5878. We now multiply 15.8 times 0.4848. We can do that from a functional calculator. When we do that, it's now going to give us 7.6598. We can stop there. We're using four-figure table. Divided by 0.5878. When we do that, it's going to give us 13.03. This is cm. We can correct to 13.0 to one decimal place. cm. We have found side A of this very question. Remember, we presented the formula. Like I told you, the three must be complete. 1, 2, 3. It's true you are using 2. We now substitute 15.8 over sine 36 is equal to A we are looking for over sine 29. We cross multiply. A times sine 36 is A sine 36. equals to 15.8 times sine 29. To single out AA we're looking for, we divide by sine 36. And what we do to the left, we must do it to the right. Then we find the value of sine 29 that gave us 0.4848. We multiply it by 15.8 and that gives us 7.6598. Remember, I first of all presented the value of the numerator. I did not multiply and divide straight away because in your standard exam the marks are given in stages. If you jump a stage, you may lose the mark. First of all, the value of the numerator, 15.8 times 0.4848, which is 7.6598, then divided by 0.5878, which is the value of sine 36. And when that is done, this is what it has given us. That is, when two angles and one side are given, this is what we expected to do. Another example is when you are told to solve completely. When the question says solve the triangle completely, it means you expected to find all the ungiven angles and all the ungiven sides when you are asked to solve completely. Let's take an example to that effect. Here we are told we are given triangle PQR. In triangle PQR, we are told here that angle P is equal to 115 degrees, while side P is 65 cm. And side Q is equals to 32 cm. And then we expected to solve completely. I said the solving completely means find all the ungiven side and all the ungiven angles in that very particular question. We go on to sketch P, Q, R. Angle P is 115 degrees, while side P is 65 cm. And also side Q is 32 cm. That means we expected to find side R, angle Q, and the angle R. We present our formula that A over sine A equals to B over sine B, and that's equal to C over sine C. We now substitute the given values. We have 65 over sine 115 degrees, and that is equals to 32 over sine Q. We cross multiply. We now have 65 sine Q is equals to 32 sine. Now we cannot get angle 115 from the four-figure table. Since we are using four-figure table, we now find the supplementary value of this very angle by subtracting this 115 degrees from 180 degrees. So 180 minus 115 will give us 65 degrees. That is the same value. Now we continue. This is 65 sine q divided by 65 is equals to 32 sine 65 degrees divided by 65. Remember that this 65 is the side centimeter. So 65 cancels 65, therefore sine q is equals to 32 times, we find the value of sine 65 from the 4-figure table. Sine 65 from the 4-figure table, and that will give, that is, the value is 0.9063. 0.9063 divided by 65. So we multiply the 32 times 9065. We do the multiplication. That will give us 29.0016 divided by 65. When we divide 29.0016 divided by 65, that will give us 0.4462. This is the value of sine q. The value of sine q. We now find the angle from the same 4-figure table, and that on the body we look for this very value to find the angle. If we do that correctly from the 4-figure table, looking for 4462 from the body of 4-figure table, that will give us 26.5 degrees. And that is angle Q is equals to this. All these ones is sine Q. This is angle Q. We have found that angle for this. That is 26.5 degrees. Then we go on to find the rest. Go on to find the rest. And what do? We have already got two angles. We have got this and we are given this. We now say angle R is equals to 180 degrees minus 115 degrees plus 26.5 degrees. That will give us 180 minus the sum of this. This is 0.5. 5 plus 6 is 11. Carry 1. 1 plus 1 is 2. 2 plus 1 is 3. And that's 1. And when we subtract that, will give us 5. This remains 9. 9 minus 1 is 8. This remains 7. 7 minus 3 is 4 degrees. We have found the third angle. We can now look for side R. Side R. We just apply the same formula we use in finding other aspects to find this very side R. I hope you are following. So we go on. So we have found this very angle. We now go on by saying, already we have presented the formula. We don't need to repeat that formula again. We simply say that 65 over sine 115 degrees is equals to R over what we find for R, and that is sine 48.5 degrees. So what you do, you cross multiply and solve on to find the value of r in this very instance. The value of r in this very instance. I know you can do that. Just cross multiply and then single out r. You find the value of, remember we said that this is the same thing as 65 degrees. Okay, this is r sine 115 degrees equals to 65 sine 48.5 degrees. R sine 115 degrees divided by, remember I told you this is sine 65. Let me straight away write it here. 65 degrees divided by the same sine 65 degrees is equal to 65 sine 48.5 divided by sine 65. So we single out r and then we find the value of 48.5 degrees, multiply it by 65 and then find the value of sine 65 also from the fourth figure table, substitute that, multiply first and then divide. This is, when we do that, we now collect our answer. Remember what we have been looking for. We present them one by one as a summary of what we expected to do. So this is solving oblique triangles, a non-right angle triangle. When we are given two sides and one angle, and that one angle must be opposite one of the given sides. Or when we are given two angles and one side, we apply sine rule to solve that very problem. Another aspect, another way of solving oblique triangle is what we will treat next. That will be our cosine rule. We will treat it in our next meeting. I still request that you subscribe to sirMATHS so that you follow us in our this daily discussion in mathematics world. You will enjoy it. So don't fail to do that. What we treated today is oblique triangles, which is the same thing as non-right angle triangle. A triangle that the angles are all acute, the triangles are all acute, or one of the angle obtuse and the other one acute. We apply sine rule when we have the two conditions we have already stated. So for today, we are ending here. Thank you for subscribing. Thank you for joining us in this move. Till next time we meet, God bless you.